Hey there, my name is Alejandro, and welcome back for day 71 of me doing the Daily LeetCode Challenge until I reach 1 year's worth of green contributions here on GitHub. So today's problem is for September 25th, 2024, and let's get straight into it. Okay, today we get a LeetCode hard, problem 2416, sum of prefix scores of strings. Okay, you're given an array of words, words of size n consisting of non-empty strings. We define the score of a string word as the number of, the score of a string word as the number of strings words I, such that word is a prefix of words I. Okay, for example, if words equals A, B, C, A, B, then the score AB is 2, since AB is a prefix of both AB and ABC. Okay. Okay, I'm instantly thinking tries here. Return an array answer of size n, where answer I is the sum of every of every non-empty prefix of words I. Okay, we definitely need to see an example. So, okay, ABC, AB, BC, and B. Okay, 5, 4, okay. Is it going to be... For string is the following. ABC has 3 prefixes, A, AB, and ABC. There are 2 strings with the prefix A. 2 strings with the prefix AB, and 1 string with the prefix ABC. The total answer is 0, 2 plus 2 plus 1 equals 5. Okay. Okay, there's got to be, okay. So the point is that, like, okay, so this one, so you essentially go for every prefix of this word and count how many times that prefix happens. So it's like you always add the length of the prefix, essentially, right? Or you essentially do, like, you essentially get the longest prefix that exists, and then return, like, sum of 1 up to that length, right? 1 plus 2 plus... So 1 plus 2 plus 3 here actually gives you 6. Wait, so... Oh no, so A happens twice. Okay, so ABC happens once in itself. So every single string is going to have a 1. Okay, let's reread this problem. You're given an array words of size n consisting of non-empty strings. We define the score of a string word, okay, a word in words, as the number of strings, words I, such that word is a prefix of words of I. Okay. And the score of AB is 2, since AB happens in itself and ABC. So everything is default going to have 1, right? Because everything is a prefix of its own self. Okay, what are the constraints? Oh, okay, these are very loose constraints. So this means we can go all the way up to n cubed, right? Because 1,000 is essentially 10 times 10 times 10, which is 10 to the 3. And usually on LeetCode, you can get away with anything to 10 to the 6. Okay, I was thinking of a naive brute force solution that I thought it was in squared. Is it not in squared? Or, okay, wait. Words of I dot length. Oh, words. Yeah, okay. So, no, but there's up to 26 letters in the English alphabet. And these are lowercase English letters, right? So if I have a try, it's going to have at most a depth of 26, right? So let's think about this. If I did the trivial solution, which would be like, okay, go for every word. For every word, go through every prefix of that word. Ouch, okay, this is going to start to get complicated, right? So this is 1 plus 2 plus dot 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 plus 1,000. So this is a factor of n squared, right? Usually this is like, so if I do 1 plus 2 plus 3 plus dot 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 plus 5 plus 4 plus 5, let's say, or plus n, this is equal to, I think, n times n plus 1 over 2 or something like this, right? So it's like if I do, if I pull up my terminal here, right, and I do sum of, let's do some import random, n equals random.randint, let's do some number between 51 and 151. And then we do sum of I for I in range 1 to n inclusive. And then if I do n times n plus 1 over 2, then yeah, you see these two numbers are correct. Okay, so essentially, yeah. Of n squared of n of n. Otherwise, go through every prefix of that word and then check if that prefix happens in the try, right? At some point, ooh, oh no, you can't get greedy, right? And check the whole thing. Okay, but the point is that you can check up to the length, right? So it's like, for something like ABC, right? I see that all of ABC is in there. Wait, okay. An array, okay. The score of a word is that of size n where answer I is the sum of scores. Wait, the sum of scores. So it's not the score of each word, it's sum of scores of every non-empty prefix of words I. So it's like, oh my goodness, okay. Where answer I is the sum of scores of every non-empty prefix of words I. Okay, for every word, go through every prefix of that word. Essentially, you count. Is this not, this is just n cubed, right? Something like this will work. Right, this is n squared and we do it O of n times. And each one, the depth of the try is at most 26. So times 26, right? 26 n cubed is still n cubed. I mean, let's try it, right? Okay. First thing is step 1. Build a try. So, okay, yeah. Definite. Equal to this. For word in words. Self dot insert word. Word. So def insert word of self. This is essentially going to do try is equal to self.try. It's going to take in a word for letter in word. If letter not in try, try of letter is equal to a new dictionary. Otherwise, try is equal to try of letter and return. Def is prefix self comma word. Actually, I'm going to have to be more careful with this. Or like something like get prefix sum, right? So for now, let's leave that empty until we don't need it. Okay, so now let's print self.try and return an empty array. Right. ABC, BC, AB is in there, and there we go. So maybe we could leverage something like the try, where it's like we traverse the try instead of the words. So there's a lot of repeated work here, right? So it's like, here I do AB, and here I'll have to do AB again, right? This was fine. This took O of n time. Right, because this is technically constant, and you just iterate over the words. Now we could go through every prefix of that word, right? So it's like, answer is equal to this for word in words. Oh, why is this off center or whatever? Okay, I gotta think. I mean self dot get prefix sum of words. Res equals this. Answer dot append res to answer. Is this something just as simple as like or maybe it's like so if letter is not in try, we do this. Otherwise, we like add 1 to the number of prefixes we've seen for each one. Something like this. I gotta really understand this problem. Return an error. The answer for each of the following. ABC has 3 prefixes, A, AB, and ABC. There are 2 strings with the prefix A. So essentially in this try, I could keep track of a hash map, right? Self.d is equal to this. Or inside the try, right? Where it's like every single thing. So like this represents, so the try could have a prefix count is equal to some integer. Prefix count is going to be equal to 1. Or we can make this equal to 0. Try prefix count plus or equal to 1. So here we can do print self.try, return an empty array. It's going to complain about this guy. So A, let's do prefix count. Count, or prefix count. So A happened twice, right? AB happened twice. ABC happened once. Then let's look at something. AB has 2 prefixes A and AB. There are 2 strings with prefix A, indeed, and there are 2 strings with prefix AB, indeed, right? So essentially, now I could essentially get, for every string I can traverse and keep summing the prefix counts, right? And something like that. Def get prefix sum self comma word. So now essentially I've kept track of that extra metadata where it's like every time I'm inserting a word, I'm essentially counting the number of times that prefix occurred. And so now I can do get prefix sum. We'll do res is equal to 0. Try is equal to self.try for letter and word. If letter not in try, break. And the point is that here we're going to return res, whatever it is. Otherwise, letter is in try, right? So assert that PC in try. Yeah, that's just for sanity check. Res plus or equal try of PC. Prefix count. And try equals try of letter. Over here we're going to return res, right? The point is that for every prefix, essentially, we only traverse this once, but every time we look at a prefix, we essentially keep adding that prefix count that we pre-computed before. And right, and at any point, if there's no more letter, then like, you know, if I had like AZ, it doesn't matter what else I have, I'm not going to have the rest of the string as a prefix wrong, right? Yeah, so I'm only caring about the prefix of words I. So if I've ended it in the try, I am completely done. Okay, I mean, if something like this works, this is not really hard. Okay. So get prefix sum. So right now I'm just printing the try, right? So now let's do print self dot get prefix sum of ABC. This should be 5, right? So when is PC not in try? So here, oh, I should do try equals try of letter, and then get the PC from that letter, right? Okay. Yeah. So this returns 5. Okay, beautiful. Wait, can I just literally do something like return an array of self.get prefix sum of word for return map Oh my goodness. Okay. Let's run something like this. Oh my goodness. Okay. And beats 90%. Oh my goodness. Okay, boys. All right. Well, okay. This wasn't really a LeetCode hard. This was, okay, this was a little teaser. All right. This is nice. This is very nice. Okay. All right. Okay. Oh. All right. Let's clean this up a little bit. Oh, I'm happy. Okay. Def self.d we didn't even need. Prefix count. PC int for prefix count. Prefix counts. Right, so we initialize that way. You don't even need the return here. Okay. Yeah, okay. Let's resubmit and so on. Okay, 89.31, 90%. Okay, bada bing, bada boom, ladies and gentlemen. Okay, that's awesome. Okay, I don't know. I was kind of surprised. I mean, yeah. Is this n squared instead of n cubed? So like they essentially give you room for n cubed solution. So let's think about this. So for word and words, okay, this is definitely O of n, right? I'm looping over all the words, which is O of n, and each of them I'm doing constant word, right? Because the word is at most, okay, it's at most 1,000 in length. Okay, so word's length, let's assume that both of these are 1,000. Okay, this is technically, you know, like a word could be like really, really long, but I guess the max depth isn't necessarily 26. Where it's like, yeah, you could go A. Okay, I was smoking when I said the max depth of a try is 26. It's definitely not. It's up to 1,000. So okay, so this is technically, if you assume both of them are 1,000, right? Then it's like 1,000 times 1,000. So I'm gonna say like at most n squared, right? And then this get prefix sum. So the point is that I've pre-computed all the prefix sums. So essentially for each word, I'm essentially gonna traverse the try once and do a running total of the prefix counts because I essentially put those efficiently. So for each word, so I might go up to a depth of 1,000 and for each word. So essentially this is the same exact running time complexity as this. If we assume them to both be 1,000, we essentially have 1,000 squared. So if we assume this to be n and, you know, and say like, hey, this is less than or equal to n, then, which I guess is not necessarily the case, essentially take the max of these and square that, and that's your running time complexity, right? So that's essentially it. Okay, perfect. So we have an effective n squared solution when they really gave us room for n cubed. So I guess that's why our running time is very, very efficient, which is, you know what, awesome sauce. All right. Okay, as always, I'll explain how I was able to build my solution to the problem. Essentially, in this case, all I'm doing is like, okay, I recognize, so we want the sum of the prefixes of each word, right? So for like a word like ABC, we're gonna have a result of 5 because each of the prefixes of words of this word are A, AB, and ABC. And for each one of them, you wanna count how many times that prefix has ever occurred, right? So it's like, ABC only occurs once because there's only one string ABC and everything there's never been ABC as another prefix. But something like AB has happened here in the word itself as well as in this one, right? And so in something like A has happened here, has a prefix, here has a prefix, and that's it in this example and so on. But that's kind of the point, right? And so here it would be 2 plus 2 plus 1 equals to 5. And so essentially the trick that I kind of leverage is, okay, let's build a try, because a try is like usually like pretty obvious whenever you're trying to deal with prefix of words and so on and da. We've been getting kind of a lot of try problems lately. And essentially the clever little thing that I did is like, okay, for each prefix in my try, let's keep an account of an additional thing, which is like whenever I go through a letter in the try, that means that I have reached via another word that prefix, right? Every time I add a word, insert word into my try, and I'm going through a specific letter, I'm going to increment the quote-unquote PC, so prefix count, by a value of 1 because I've just reached that letter another time, right? So it's like if I have A, B, C at the beginning, I'll have A, B, and C, and they'll each be 1, right? Because I've only ever reached them once. But then when I get through A, B, then I go through A, I increment that value by 1, right? And so the point is essentially like I've been able to reach the prefix of A with this string as well as with this string, right? So it'll have a value of 2. So there's at least 2 strings that I've been able to reach that prefix through, right? And then when I add the B, same thing. This B will now have a PC or prefix count value in here of value 2. So if I print this try here, so if I do print self.try after inserting all the words, so you see in this example, for example, after we add every single word in here, you'll see that like A has a prefix count of 2, which makes sense because it's like A has it 1 in here and 1 in here, and whenever we added that word, we'd essentially add that prefix, like we augment that quote-unquote prefix count by 1, right? And so something like B should also be 2, right? So yeah, so B is also 2. And the point is that when I add BC, you know, I'll add a prefix count for B if it doesn't exist, starting at value 1, and otherwise if I've seen it again, I just augment that value by 1, right? So for essentially every prefix in the try, I have a value that tells me how many words have had that prefix, right? And so that's kind of the clever thing I can leverage, because then all I can do is for each word, just traverse the try and get the sum of the prefix counts, right? Where it's like for something like ABC, it's like, okay, I need to go through A and then B and then C. And then here it's like, okay, A, I get the prefix of count of 2. So so there's at least 2 strings, including itself, that has that prefix count value. Then I go into B, and again I add this 2 because there's at least 2 strings that have had this thing, exactly 2 actually, not just at least 2. And then I go in through C, and there's only one string that has ever had this full prefix of A, B, and C, which happens to be this string literally itself, and I just take the sum of those values, right? So it's essentially like when I do get prefix sum, I start at a res of 0, I keep going through the try as long as I can, right? As long as I'm going through a prefix that legitimately exists in the try, which means I will go through the full word because there's at least the full word inside of the try. And essentially every single time for each letter that I go through in the try, I essentially add that prefix count, and there you go, bada bing, bada boom, and there you have it. So, okay. I hope that explanation kind of makes sense. Again, like if you're able to follow along with that idea, the point is that every single time I add a word, essentially to every letter in that word, I'm going to augment the prefix count by 1, right? So if I'm adding AB, the original A inside the try, its prefix count will be added by 1, and then at AB I will add that value by 1, and so on. So like A and then B, so like this PC count I'll have augmented by 1. So for every word, like every letter in that word's prefix count, right, up to that prefix, will have its PC value or prefix count value augmented by 1. So that way, when I can just go through each word again, traverse the try, and as I traverse the try, just get the sum of all the prefix counts as I traverse that full try, right? Where it's like, if I traverse ABC, at A, I'll have the sum of all the strings that have a prefix of at least A. Once I get to B, I'll have a prefix count representing the sum of all the strings that start with at least AB. And once I get to ABC, all the number of strings that have at least a prefix ABC in count, right? And so I essentially add that for every word. And there you go. There you have it. I have an n-squared solution, and it works nice and beautiful. So yeah, I hope that explanation makes sense. And otherwise, that's pretty much it for this video. In case you want to do something similar to what I do, by the way, the extension that I use is called LeetSync. Essentially, what these guys do is whenever you submit a problem here on LeetCode, it'll automatically post a copy of your solution here onto your GitHub repository. So here, if I'm able to load it, sum of prefix scores of strings. So you'll see I submitted something 7 minutes ago, and essentially the very first time you upload the problem, it'll post a copy of it as a readme.md file for the description, as well as every time you resubmit a correct solution, it will update that solution onto your GitHub. So very, very useful extension in case you want to do something similar to what I do. But of course, always do your own due diligence before you trust a random guy like me on the internet. But as always, I figure I just showcase my setup in case you like what I do and you want to do something similar. So that's all. And otherwise, that's pretty much it for this video. If you did find it useful or enjoyable, I would highly appreciate it if you left a like or a comment. If you do leave a comment, I promise to respond to every single one of your guys' comments, even if it's LeetCode related or not. So if you want to talk about your hobbies, for me it's like chess and pickleball and all that, feel more than free to talk about it here in the comments, and I promise that I will have a chat and respond to every single one of you. Of course, if you do talk about LeetCode or CS and so on, I will definitely have a conversation with you as well, because that's what this channel is all about. But yeah, I just want to make you feel like welcome in case you want to share your opinions on absolutely anything, technically related or not. I'd love to have a conversation with each and every single one of you. But otherwise, that's pretty much it for this video, and I'll catch you in the next one. So until then, ciao, ciao, my friend. Bye-bye.